everyone, I am Madam Rosmaya. Welcome to my YouTube channel. So in this video, we are going to discuss on physics, PU Physics Semester 3. The topic for today is proving the equation for refraction at a spherical surface. So the equation is given by n1 per u plus n2 per v equals to bracket n2 minus n1 per r. So u is object distance, v is image distance, n is refractive index, and r is the radius of curvature. So recall to what we have learned before using Snell's law, where it states that sin I per sin r equals to the constant, and constant is n. N is the refractive index, I is the incident angle, and r is the refraction angle. And from here, we prove that n1 sin I1 equals to n2 sin I2, where n sin I is equals to the constant. Okay, for the incident ray pass through the medium 1 and refracted. The ray is refracted in the medium 2. So n1 is the refractive index for medium 1 and n2 is the refractive index for medium 2. Okay, the path of the ray incident at a spherical surface, you must draw two paths to get the image. Okay, imagine this is the medium with refractive index n2, and the position of object is at here, so we name as refractive index 1 n1. So the first path is where the ray is incident along the axis of the refracting surface. Axis is drawn from the object to the center of the spherical surface here. So this is where the object is. That's why we name 1 here and 1. Okay, so imagine the curve make a spherical shape. So the sphere, the center of the sphere is C. So you draw the line joining object and C. So this is the axis, the principal axis. And at the boundary here, we call this point as P. So the path follow this axis does not bend. So next, we draw the path of the ray incident at point A. So point A is other than point P along the curve. Okay, so the ray will be refracted towards the normal. Because the density, the refractive index of medium 2 is larger than the refractive index of medium 1. Therefore, the incident ray will be refracted towards the normal. So first, we draw the normal line to the curve, the curve here. So to draw the normal line, the line must be drawn towards the center of the sphere. Okay, let's call this point as A. So when you draw the ray towards the A, from the object towards the A, so it will refract after the curve pass through the medium, so it will refracted towards the normal. Okay, next, the image form at the intersection point of the two rays. So let's name this image as I, and the image form is a real image. So now we name the angles in the diagram here. So the incident angle we call as I1, the refraction angle I2, the angle here is A, angle at C is B, and angle at I we call C. Okay, at point A, using the triangle AOC, so I1 is A plus B. So we use triangle AOC to get I1. Okay, so this one you've learned in maths, form 1, form 2, form 3. Okay, And then at point C, we use triangle ACI. ACI. So the angle B here is equals to I2 plus C. So we rearrange these equations, become I2 equals to B minus C. Okay, since point A is close to point P, so the angles I1 and I2 are very small. So sine I1 equals to I1 in radians, sine I2 equals to I2 in radians. So we can rewrite the Snell's law equation just now. This equation becomes N1 I1 equals to N2 I2. Okay, then we substitute I1 and I2 into the equation here. Becomes N1 bracket A plus B equals to N2 times bracket B minus C. And we expand this bracket, become N1A plus N1B, bring to the right side, become minus N1B. Then N2 times B bring here, and N2 and minus N2C we bring to the right side. So we rearrange the equation here, we get this. And then we factor out B on the right side, so bracket becomes N2 minus N1. Okay, so this is all mathematics. So we can rewrite this equation by using trigonometric ratio for A, C and B. Okay, so we use trigonometric ratio. So before that, we name the distance object as U, object distance as U, image distance B, and then the radius PC of the imaginary sphere just now as R. So we name this R as radius of the curvature. So using the height of the triangle here is H. So we use trigonometric ratio for tangent. Tangent theta is opposite per adjacent. Okay, and we also can use tangent theta equals to theta for the point A very close to P. So tangent, let's say tangent A, so equals to A. Okay, then for this triangle AOP here, okay, so A equals to H per U. Opposite H, adjacent is U. Okay, then for B, you use this triangle. So opposite is H and adjacent is R. Okay? So can be equate to R because A is very small to P. Okay, so A is close to P. So you can assume PC equals to R. And the point here is approaching R for A close to P. And then for the C, we use triangle, this triangle. So opposite is H, adjacent is V. Okay, next we substitute A, B, and C into the equation. Okay, then we can cancel out H, and we rewrite the equation here becomes N1 per U plus N2 per V equals to bracket N2 minus N1 per R. So it is proven the equation for refraction at a spherical surface is proven. Okay, if you use N1, refractive index N1 larger than N2, you will get the same formula, but the N1 is here, and here the bracket here becomes N1 minus N2. Okay? So as a conclusion, for the equation N2 minus N1, generally we can say that N2 must be larger than N1. Okay? So this is positive, always positive value. Okay, for the object that is real, the value of U is positive. For the image, always real, so the image is positive. And for the radius of curvature to be positive, the center C is in the denser medium. Okay? Example here, N1, N2 larger than N1. Okay, N2 much larger than N1. So the center C is in the denser medium. So the R here is positive. And for the negative value of U, the object virtual will be negative. The V will be negative if the image is virtual. And the radius also negative if the center is in the less dense medium. Example here, this is object facing the concave surface. So C is in the less mediums. So N1 is larger than N2. So C is in the less medium. So always remember the sign used for the equation proven just now. Okay, let's try this question. Example 1. A point object is placed in front of a spherical surface of radius curvature 10 cm. So the refractive index of a glass is 1.50 and determine the position of the image when the object's distance is 20.0 cm and 5.0 cm. So we do the question A first. So from the equation here, proven just now, what is N, what is U, and what is R. So radius of the curvature is 10. So this 10 is positive or negative. So you determine using where the C is. The position of C here, glass has larger refractive index compared to air. So N glass larger than N air. So the center of curvature is here in the denser, in the denser medium. Okay, so therefore R is positive. So the objects lies at the N1, in the medium with N1. Okay, so R is positive. Next, the N2 will be N.50. Okay, N1 will be air. In air, N1 is 1. And then we are going to determine the position of the image. So we are going to determine the V. And the object's distance here given is U. So U is positive because the object is real. Okay, so using the equation here, we substitute N1 equals to 1. For air, N1 is 1. And object distance 20 cm. So N2 is glass 1.50. So V, we are going to find V. And N2 minus N1, always larger minus smaller value. So 1.5 minus 1 divided by radius of curvature is positive 10. So we solve this, we get V equals to infinity. Okay, now to sketch the ray diagram. To sketch the ray diagram, okay, there are two rays. Remember just now, two paths to be drawn. The first path follow the principal axis. Okay, so it does not bend. The second path, okay, at other point it will refracted towards the normal. Okay, so when you draw V infinity, what is meant by V infinity? So the refracted ray is parallel to each other to show that the image formed at infinity. So this is to sketch the ray diagram for image at infinity. So the ray must be parallel to each other after it's passed through the second medium, which is denser medium. Okay, so next we do for B question. Okay, 5 cm. So the same equation. So 1/5, this time object distance is 5 cm. So we substitute 5 for object distance U. And we are going to determine V. And N2 minus N1, the same thing, 1.5 minus 1, larger minus small value. So the V we get negative 10 cm. Okay, negative 10 cm. So how to sketch the ray diagram? So there are two paths. Okay, the object here U is 5 cm. And the image here is 10 cm. So what is meant by negative here? Negative means the image is formed on the same side as the object. Okay? So the image must be somewhere here. Okay, so if you draw or sketch the ray diagram, the position must be logic. If this is u 5 cm, so 10 cm must be larger than 5. Okay, about double distance of u. So your draw must be logic. So the image must lie somewhere here, negative. So it must lie on the same position as the object. Okay, so next, how to draw? First, you draw the line. You can draw backward from the image first. The image, you draw a straight line. Okay, but remember that this line is the imaginary line. Imaginary line. Okay, so you draw dotted line. For imaginary line, imaginary ray, so you draw dotted line. So this is where the ray refracted to in the medium, the glass medium. So the ray must comes from the object. So you draw another line. It's a solid line because this is not the imaginary ray. This is the actual ray. So the ray comes from the object, then refracted refracted towards the normal in the glass medium. Okay. So you draw arrow. And another ray is the ray comes from the object, pass through the principal axis, which join the principal axis is the line join the object and the center of the sphere, imaginary sphere. Radius of the curvature here, inside here. So C is somewhere here. So the ray, this ray does not bend, doesn't bend. So you draw a straight line. So therefore, this line drawn here to I must a straight line. Must be drawn a straight line. So that's why we sketch the ray diagram backward just now, so that you don't make mistake of this line, especially this line. From my experience, many students draw this line as a curved line, not a straight line. So that's why we draw backward. You must really understand how the ray is drawn. Okay, next we go for the second example. Okay, second example. A point object is at a distance of 15 cm from a concave glass surface of radius of curvature 5.0 cm. So the refractive index of glass is 1.50. Determine the position of the image when the object distance is 15 cm and 2 cm. So the solution, we solve for 15 cm first using the equation here. So R is a center of a radius of curvature, so positive or negative. So look at the diagram here. Object is facing the concave surface. So N2 is denser than N1 because here glass, this one air. So N2 is denser than N1, and the C is in the less dense medium. Okay. So therefore, center of the sphere here. Imagine this is the imaginary sphere. So C is in the less mediums. So therefore, R is negative. So this 5 is negative 5 cm. Okay, now we can substitute into the equation for N2. N1 is the air, and we are going to determine V, object, this image distance, and this is object distance. So substitute into the equation here. Remember that N2 minus N1, N2 must larger than N1, so therefore 1.5 minus 1. So solve for V. So V is negative 9 cm. So what is meant by negative? For negative, it means that the image is in the same position as object. Okay, on the same area as the object. So to sketch the ray diagram, so this is 9 cm. Object is at 15 cm. So object is at 15 cm. So this is 15 cm. So 9 is somewhere in here, in front of the object. So to draw, determine the position of the image is, so it must lie somewhere here, not behind the object but in front of the object, because only 9 cm. Okay, and negative means it's at the same area of the object, so it's in the air, it's in the air. So this is the image form. Okay, to sketch the ray diagram, you can start with the image. You draw a straight line, and the ray on the air area here is a imaginary ray. Okay, because we draw here from the image. This one is the imaginary ray. It's not the actual ray actually. So this ray is the refraction ray. So the incident ray must come from the object. So you draw another line. So you complete the ray, the actual ray. So again, I repeat, this is the actual ray, comes from the object. When it comes, when it refracted in the glass, so the refracted ray is towards the away from the normal, because this is the concave surface, so refracted towards the normal. Away from the normal, sorry, away from the normal. So you don't forget to draw the arrow. Sorry again, it is refracted towards the normal, because denser. The ray is incident towards the denser surface. So the ray is refracted towards the normal. Okay, so another ray is drawn, does not bend if it follow the principal axis. Okay, next we do for the second question, 2 cm. The position of the image when the view is 2 cm. So using the same equation, we solve for V, but the U here replaced by 2 cm. So we get V equals to negative 2.5 cm. So again we get negative. So what does this mean by negative? Negative means that the image is formed on the same position as object, same area as the object here. So the object is 2 cm. Okay, so this is the 2 cm distance. So 2.5 mean behind the object, the image form here. Okay, first step, you draw the straight line here towards I, and the part here is the imaginary ray, so you must draw dotted line. Okay, then you continue the bend ray here, where the incident ray, actual incident ray, comes from the object. Then when it passes through the glass, so the ray is refracted towards the normal. Okay, then don't forget to draw arrow. Then another ray is the ray pass through the principal axis, which does not bend. So this is the line joining the object to the center. The center is behind here. Center is in the less dense. Okay, so this is the principal axis. Okay, now we compare these two ray diagram for the concave surface. So if the object is at 15 cm, okay, where it is larger than the radius of curvature. So radius of the curvature is 5 cm. Okay, so 15 cm object larger than center of curvature. So the object 2 cm means less than center of the curvature 5 cm. So no matter where the position of the object is, which is larger than the radius of the curvature or less than radius of the curvature, the image form is always virtual. Okay, the image is always virtual because we get V negative. So it lies on the same position of the image. Okay, the image is always located in the same medium as the object. Okay, so that's all for the video. Thank you for watching. So I leave you one question for you all to discuss with your teacher or friends. And good luck to get the answer for this exercise. Thank you again for watching.